Hello fellow viewers, welcome back to another video. Today we're going to be talking a bit about coordinate geometry. Now in the past you might have learned that c square will equal to a square plus b square. Now this is your Pythagoras Theorem. Alright, so your c square, which is from the c here, and your a square and b square, which is from the b here and the a here. Alright, so now we're just going to take a look at an example on a graph. So over here I have two plotted points A with the coordinates 3 and 5. So the 3 comes down here, the 5 is here, and then I have a point B with the coordinates -4 and -4. So it's just one -4 here and a -4 here. Alright, this graph is not drawn to scale, yeah? Just a rough sketch. I want to find the distance between A and B. So that's just the length AB. So how do I do that exactly? I'm just gonna get rid of these points here. Alright. So as you can see, if I just draw a vertical line directly down from A and a horizontal line reaching to that vertical line, I create a right angle triangle. And I'm just going to call this point over here C. Alright? So using what we just went through just now, c square equals to a square plus b square, we will then understand that ab square will equal to ac square plus bc square. But here's the issue. How do we find AC and BC? Now I just want you to take a look at it over here. Let's take a look at the y side first, okay? So for point A, our y value is 5. So we are technically 5 units away from the x-axis. For our b point here, we are -4. So we are technically 4 units down from the x-axis. So 5 units plus 4 units equal to 9 units. So AC is actually just 9 units. Now we move on to BC. So BC is technically on the horizontal side. So we'll look at the horizontal difference now. So point A is 3 units away from the y-axis. And point B is -4. So point B is actually 4 units away from the y-axis. So 3 units plus 4 units equals to 7 units. So technically BC equals to 7 units. So now we can actually substitute in our values. So AB square actually equals to 9 square plus 7 square. So therefore, AB equals to square root of 9 square plus 7 square. So if we write that down, we'd actually get 11.40175. And we'll just round it off to 3 significant figures. So it's AB is actually 11.4 units. So that's how you find it. But this way, it looks extremely complicated, and it'll actually confuse you even more if you don't have a great understanding on this. So there's actually a formula to memorize. So back to this again, I'm just going to do a quick sketch. Looks a little crude, but it's alright. This is AB. Okay. So it's the same coordinates as just now. And the formula, right, is actually just your length equals to the square root of x1 minus x2 squared plus y1 minus y2 squared. That's your formula. Now I just want you to pretend that A's coordinates are x1 and y1, and B's coordinates are x2 and y2. So as you can see, if you just substitute in the values, you would get your length equals to square root of x1, which is 3, minus x2, which is negative 4. Remember your bracket. And then you have y1, which is 5, minus y2, which is also negative 4. Remember your brackets. So you'd end up getting the square root of 7 squared plus 9 squared, which also gives you the same answer as above. It was 11.43 significant figures. So yes, you can. You don't really have to follow this method way. You can technically write it as x2 minus x1 square plus y2 minus x1 square. So whichever point, if you use x2 first, then your y2 has to come first later. So if you use x1 first, then your y1 has to come first later. Yes? Alright. If you got this part done, let's move on to a practice question. So over here, we've got now 2 points. We've got A with the coordinates 1 to negative 3, and we got B with the coordinates negative 5 to 5. So we need to find the distance of AB. So pretty easy. Just use that formula we just learned. Your length will equal to square root. We'll just start off with A. So we'll use 1 minus negative 5 square plus negative 3 minus 5 square. And this will give us square root 6 squared plus negative 8 squared. This is also the same as 36 plus 64, which will actually give us 100. So square root 100 is actually just 10. So your length AB is just 10 units. Alright? Okay, let's move on. So now we know, okay, now this question is saying that the distance between A and B is 5 units. So A has the coordinates of 4 to A, and B has the coordinates A to 11. So we need to find the possible values of A. For this kind of questions, your length is given, but your coordinates are unknown. So basically, what you have to do is just do the same method, formula as just now. So now we know our length, but we don't have our coordinates. So I'm just going to start with A. 4 minus A squared plus A minus 11 squared. So we just gotta... Okay, I'm just going to get rid of the square roots because it's getting really annoying. So I'm just going to square both sides. So 5 squared equals to... So 4 minus A squared is actually just 16 minus 8A plus A squared plus A squared minus 22A plus 121. Alright, then we just gotta compile everything together. So the 2A squares, when added together, you get 2A squared minus 8A minus 22A, you get minus 30A. 16 plus 121, you get 137 equals to 25. So now we want to make our right hand side 0 so that you can use any method you want to use, but usually I'll use the quadratic formula, quadratic equation. So 2A squared minus 30A, so 137 minus 25, because I'll minus 25 on both sides to make the right hand side 0, so it's just plus 112. Now we can use the quadratic formula. A will equal to negative B. So my A will technically equal to 8, or it can equal to 7. So my A values can be either of these numbers. Alright? Got it? Next question. Alright. Take a look at this one. The coordinates of triangle ABC are -3 to -1, and 5 to 1, and 2 to 4. Calculate the lengths of AB, BC, and AC. So the first one is just a 1-by-1 step question. Just gotta keep substituting in. So the length of AB will actually just equal to... Just gotta be careful, don't rush it. You might make careless mistakes. Then you will get... So AB is square root 68. What about BC? BC is square root 18, and AC, lastly AC. Running a little bit out of space there. Okay. So we get... So AC is just square root 50. So we've got all the lengths now. So for part B, we have to show that triangle ABC is a right angle triangle. So basically, we know that the right angle triangle, the hypotenuse is the longest side. So we're just gonna leave this out first. We cannot make assumptions yet, so we just gotta work things out. So by using the Pythagoras Theorem, we can also prove that it's a right angle triangle. So I'm just going to do that right now. BC squared plus AC squared is equal to square roots of 18 squared plus square root of 50 squared, which will just give me 68. And then AB squared equals to square root 68 squared, which is just 68. So since BC squared plus AC squared equals to AB squared, therefore triangle ABC is right angle triangle. Alright, so this is for part B. Now add another page. Calculate the area of triangle ABC. Now, since we know that triangle ABC is a right angle triangle, we don't have to use your half AB sine C. We can just use that formula we used last time. Half times base times height. This only works for right angle triangles. So basically, it's half times square root 18 times square root 50, and it will give you 15 units square. That is your area. Alright, so we use this. So for part D, calculate the length of the perpendicular from C to AB. Interesting. Alright, so we have our right angle triangle here. We know that AB is the longest. Okay, we also know that C is down here, so this is technically 68, this is the 51, this is the 18. So they want us to find the perpendicular going down. The perpendicular means that it is 90 degrees to AB on that line. So we need, since we have the area now, so we know that this whole thing is just 15 units squared. And we also have the longest length here. So technically, if we multiply the area by 2, we would get a rectangle. And since we have a rectangle and this length over here, that means if we divide this area by this length, we will get the area of this side, which is also the same as the perpendicular length. Alright, so let's just do that real quick. 15 times 2. Alright, after that, we just divide it by square root 68. And your answer is 3.638034. And we just round it off to 3 significant figures. So that makes it 3.64 units. That's for part D. Alright, we're done for this question. Probably the last question now. But before we do that, I have to teach you the gradients first. So basically, when you're younger, you probably learned that the gradient is the rise over the run. For coordinate geometry, something like the length, it's your y1 minus y2 over x1 minus x2. So if your gradient goes this way up, it's a positive gradient. If your gradient goes this way down, it's a negative gradient. If your gradient is just a horizontal line, then your gradient is just 0. And if your gradient a vertical line, then it is therefore undefined. Right? Why? Because you're going up the hill, so you're making progress. That's why it's positive. You're going down the hill, you're just making improvements, so it's a negative. You're staying on a horizontal line, so you're just being constant, so it's just a 0. Can't really climb a wall, can you? Alright, so this question is the line joining the points -2 to 3 and 6 to -1 intersects the x-axis at the point T. Find the gradient of the line. Okay, so first we gotta find the gradient of the line first. So our gradient of the line, our gradient formula is just y1 minus y2 over x1 minus x2. So we just gonna substitute in just any random values. So for y1, I'm gonna use q first. So 3 minus -1 over -2 minus 6, and that will give us 4 over -8. And 4 over -8 is just -12. So that's your gradient. Alright? So now we've got our gradient done, we need to find the coordinates t. And just so in case you can't visualize this, I'm just going to draw it out for you. This is your x-axis, that's your y-axis. So you've got 2 points on this for this axis. You have point Q, which is -2 to 3, so it's around here. It's just an estimation. And then you have R, which is 6 to -1, so it's around here. So your point T intersects the x-axis. Oh wait, no, your two lines, the line connecting both of them, intersects the x-axis at point T. This point over here is T. All right. And since T lies on the x-axis, that means T's coordinates are technically x. We don't know the x value, but we do know that the y value equals to 0 because the x-axis cuts through the y-axis at point 0. It cuts through the y-axis when the y is 0, okay? So now we know that since T lies on the same line as QR, the gradient will therefore be the same. Sorry, my bad. Gradient will therefore be the same. So if we just work this out, just use a different color pen now. We sub in any value. For now, I'm just going to use Q. So 3 minus 0 over -2 minus y. Okay, so T's coordinates is x to 0. So we're just going to sub in that value. It will give us the same gradient as just now, -12. That's how we know. I'm just going to make a new page because I ran out of space. Okay, so now we have this. We can just cross multiply the values. First, 3 -2 minus x equals to 1 over 2. So we'll get 6 equals to 2 plus x. So x therefore equals to 4. So thus, T's coordinates equal to 4 to 0. And there you have it. Your answer. Alright, so that ends of today's video. Thanks for watching. Hope this helps.